Resolve the forces vertically, 1 mark. Resolve the forces horizontally, 1 mark. A2. So you've got a force here, T1, here, T2, and here, 75.5 G. Part A1 is vertically, so this is T1 cos 40, and this one here is T2 cos 50. And now, part 2, horizontally, so this is T1 sine 40, and this is T2 sine 50.
And that's all?
That is all.
I mean, we don't have to do like T1 sine 40 equal to T2
That's part B,
oh, okay.
which is find T1, T2. So you can say T1 sine 40 equals T2 sine 50. And you can also say T1 cos 40 plus T2 cos 50 equals mg. Right, so let's see what we have here. We have T1 sine 40 minus T2 sine 50 equals 0. And we have T1 cos 40 plus T2 cos 50 equals 75.5 G. I want to solve this nicely. I think what I'll do to keep it nice and neat is I'll multiply this by cos 50 and I'll multiply this by sine 50, because then I'll get T1 sine 40 cos 50 minus T2 sine 50 cos 50 equals 0. And then here I have T1 cos 40 sine 50 plus T2 cos 50 sine 50 equals 75.5 G sine 50. Now, add them together. They're gone. Yeah. So now I have sine 40 cos 50 plus cos 40 sine 50 T1 equals 75.5 G sine 50. So then dividing, I get my answer. So T1 equals fraction 75.5 times 9.81 times sine 50 over sine 40 cos 50 sine 40 cos 50 plus cos 40 sine 50 cos 40 sine 50. 567.37 newtons. T2, I think the easiest way to get T2 would be perhaps to use this formula, because I can say T2 is sine 40 over sine 50 T1. T2 is sine 40 over sine 50. Yeah. So if I multiply my answer by sine 40 over sine 50, 476.08. 476.08 newtons. So finally my answer is 567 newtons and 476 newtons to 3 significant figures.
Teacher, if I got T1 is 566.58.
Is it because you used decimals here?
No, I mean, I know. Because I use first T1 sine 40 equal T2 sine 50.
Yeah.
And I got T1 as in relation of T2. If T1 equals 1.19.
T1 equals
1.19.
no, this isn't enough. You should only use 3 in the answer.
Oh.
But when you're calculating, you should use at least 4 or more. So the answer can be 3, but the work needs to be more than 3.
Oh.
Yeah.
Can I use T1 equal mg multiply 4 by 50? 40.
40. Bruce, you need to practice your numbers. You mix up 40, 50, 14, 15. Be careful. This is mg cos 40. How did you get the... Oh, because you did this?
Because the TE plus TQ equal mg.
Actually, Bruce, that's a very interesting idea. Very interesting. Can I scroll down and do it a way I think Bruce might be suggesting?
Yeah.
So look at this picture here. Well, we can't really do it this way because they tell us to use horizontal and vertical. But watch this now. If this is T1 and this is T2, how big is this angle? 90. So if I was to rotate this a little bit. Now I know it's 90, so I should perhaps draw it a bit more perpendicular than that. Okay, that's 90. How much is this one? This one is 40, and this one here is 50. Okay, now this one here is the mg. I'm sorry, my picture is ugly. I need to really fix this. No, I'll fix it. Okay, there's T2. Alright, there we go. How's that? Yeah, that's better. It's like this. 40, 50. I rotate it so that the 50 is on the ground like this. This component here, what's this angle?
40.
So this is mg. This is 75.5 g cos 40. And this angle? 75.5 g cosine 50, yeah, or the same thing as sine 40. Let's see if we get the same answer now.
I did that way.
Yes! Very good.
Problem number 2, so I'm not sure about it.
5, 6, 7?
Yeah.
Now this only works because of the 90. The 40 and the 50 makes it perpendicular. This is why it works. What I'm concerned about with this method, Bruce, is the question said horizontally and vertically. So I don't quite think we can do it this way because the question said they wanted it horizontal and vertical. Horizontal and vertical means like this. X, Y.
But that's in FMI too.
Yeah, no, I get that. It's all perspective.
I mean, isn't it
You see, and the other thing is...
That's a vertical and vertical right?
Yeah, no, the other thing is, it also didn't say by resolving the tensions. It just said by resolving the forces. So you could make the case that, well, all I've done was rotated my picture and I've resolved the forces. But which force did we resolve? We resolved the mg. So in my method, I resolved the tensions, which I feel like is what they meant. But when I read it carefully, you could make the case that, well, we can resolve the weight. But it's because they said resolve the forces with an S, not resolve the force. But it is definitely a very interesting way. And before I finish and close the video, there's a third way we can do it, but we definitely are not allowed to do it this way.
What is it?
What's the third way?
Lami.
Correct, Lami. Remember, I can use Lami here.
If I do that,
Well,
can I get 1 mark?
you can get the
Maybe.
answer. You can maybe get the 2 marks for part B.
2 marks, can I?
Well, part B was to find the tensions. Right. Do you remember what Lami said here?
Yeah.
So we can make this equation. This angle here is 90. This angle here is 140, and this angle here is 130. Right? Lami said that T1 over sine 130 equals T2 over sine 140, which also equals 75.5G over sine 90. What's sine 90? 1. So Lami said T1 over sine 130 equals 75.5G, and T2 over sine 140 equals 75.5G. So Lami said T1 should be 75.5G sine 130, and T2 should be 75.5G sine 140. Same answer, 5, 6, 7, and whatever the other one was as well. Good question, because you have 3 ways to do it, but I think they wanted you to do it the first way because of the language they used. But if they didn't say which way to do it, you actually have 3 ways to do this one, so it's quite interesting. Any other questions on this now? No? Okay, excellent. Let's go on to the next one. How many minutes do you need for that?
7.
1, 2, 3, 4, 5, 6, 7 minutes. Off you